In this video, we're going to have a look at how to solve trig problems using the quadrants of a Cartesian plane. But before we do that, just a quick recap on how to do mathematics. Number and copy the examples. Ask your tutor or teacher if there are any steps that you do not understand. Number the questions. Unless you have the ability to get fit while watching someone else run, you must do the questions on your own before watching the answers. Mark your answers. If it is incorrect, write down the corrections. Make sure you understand where you went wrong. This will enable you to do better the next time you attempt a similar sum. Now to get started, here we have the Cartesian plane, and this you have to know off by heart. So we have 4 quadrants. This is quadrant 1, 2, 3, and 4, where in the first quadrant our trig ratios, all of our trig ratios are positive. Then in the second quadrant we have sine, third tan, fourth cos, and then the first quadrant spans from 0 to 90, the second one 90 to 180, then third 180 to 270, and fourth 270 to 360. Now another way to remember this is also known as the cast diagram, so CAST, and then we want to know why is each ratio positive in the applicable quadrant. Now to do that, we're just quickly going to go and switch off the light. So let's have a look at how the trig functions fit on the Cartesian plane. We start off by sine theta. Now if I draw this graph on the x and y axis, it looks as follows. So I can see that my sine graph is positive from 0 to 180. So that is represented by the first and the second quadrant. So that's why sine is positive in the first and second quadrant. I move on to cos theta. If I draw the graph for cos theta, I see that cos is positive in the from 0 to 90 and from 270 to 360. So that is represented by quadrant 1 and 4. And then finally for tan theta, if I draw that graph, I can see that it is positive 0 approaching 90 and then 180 to approaching 270. So these are positive in the first and in the third quadrant. So now let's look at a few problem questions. Now this is the type of questions that we're going to work with, and this type of questions is extremely important because you can find the question just as it is here in your final grade 12 exam. So to make it easier, I've divided these questions into 3 parts. Now what we're going to do is we're going to solve, then sketch, and then we're going to calculate. Now solving, and let's also just look at how to identify. So we've got an equation with a trig ratio in the equation, and then we have a restriction, and then it says that calculate with the aid of a sketch without a calculator the value of tan alpha and cos alpha. So 3 things. We've got our equation, our restriction, and our sketch, or the question states calculate. It doesn't always calculate, but we always use a sketch to calculate the given ratios. Alright, now solving is we've got this equation, and in this equation we've got our trig ratio. So we're basically just going to isolate our trig ratio. So that is going to be sine alpha. We've got 13 sine alpha. So to start off, we're going to take the 12 to the other side. So this is equal to 12. And then we divide both sides by 13. So we get sine alpha is equal to 12 over 13. So that's solved, done. Now to sketch. Now we're going to use the Cartesian plane, and we need to first, before we sketch, we need to find out in which quadrant are we going to draw our triangle. So we look at 2 things. We look at this equation that we just solved, and we look at this restriction. So this restriction clearly states that it's only applicable from 90 to 270. So from 90 to 270, so it's in one of those quadrants. And then finally, where is sine alpha positive? This value is a positive value, so where is it positive? We know sine is positive in the first quadrant and in the second quadrant. So where both of these apply is the second quadrant, because sine is positive in the second, and also our restriction falls from 90 to 70. So this is where we're going to sketch. Now, before we start sketching, when you sketch, always draw you've got your radius, or your length, and then you go back down to the x-axis. So never do this. Don't go up and go to the y-axis. This is wrong. This is how we do it. Okay, so sketching, we know we need to sketch it in the second quadrant. So we draw our length and then we go down to the x-axis. And now this is our alpha. And we're going to work as if we're working out of this triangle. And with sine alpha, I know sine is opposite over hypotenuse. So that means this 12 is my opposite side and this 13 is my hypotenuse side. So this is my right angle. Opposite from this angle is 12, and hypotenuse is the one across the right angle, that's 13. Now I need to solve for this side over here, and we know in a right angled triangle, when we have two known sides, we can find the third one very easily using Pythagoras. So I've got Pythagoras, the formula for Pythagoras is that r squared is equal to x squared plus y squared, but we need to find this x value, this value over here. So to solve for that, x squared is equal to the long side r squared minus the other short side y squared. Then x is equal to the square root of r, which is 13 squared, minus y, which is 12 squared. So we're simply going to put that into the calculator. We have the square root of 13 squared minus 12 squared. So that gives us 5. So this side is then 5. Although this is negative 5, since this is in the negative x values for the quadrants. So now finally to calculate, we have a is equal to, or a is tan alpha, and tan is opposite over adjacent. So opposite is 12 and adjacent is minus 5. Then b is cos alpha, which is adjacent over hypotenuse. So cos alpha is negative 5 over 13. Now for question 4.1. So if 5 cos alpha equals to minus 3 and 0 degrees is less than alpha is less than 180, calculate with the aid of a sketch and without the use of a calculator sine squared alpha tan alpha, and for b 5 tan alpha minus 1. Right, so our first step is to solve. We have our equation and I want to find cos alpha on its own. So simply all we're going to do is just to divide both sides by 5. Therefore I have that cos alpha is equal to negative 3 over 5. Okay, and then the next step is to sketch. So to determine which quadrant, we have our restriction 0 to 180. That means it's going to be either in the first or the second quadrant. And then I look at my value here. This is a negative value. That means that cos is negative in the third or the second quadrant. So once again, we see that both apply to the second quadrant. So I'm going to draw my sketch in the second quadrant with my right angle here. So my angle alpha is this angle, and cos is adjacent over hypotenuse. And now I need to be careful with the sign, because if I have minus a over b, it can also be minus a over b, or it can be a over minus b. All of this is equal to each other. So I need to know this is my y-axis and this is the positive and this is the negative values. For x-axis, these are positive values and these are negative values. So this value over here is going to be negative. This value is going to be positive. So adjacent is then, my adjacent is this side, and hypotenuse. Hypotenuse is a length. This is always positive. So this is going to be -3 and my hypotenuse is going to be 5. So I need to find this opposite angle. And once again, I'm going to use Pythagoras. R squared equals to x squared plus y squared. So in this case, I need to find y. So y squared is equal to my long side r squared minus my other short side x squared. So y is equal to the square root of 5 squared minus -3 squared. And this is equal to, if we put that on the calculator. Now, another thing you need to be careful is now we have a negative value that we need to substitute. So you have to substitute negative values in with brackets. So this is going to be 5 squared minus, and then with brackets, -3 squared. And the reason for that is -3 without the brackets is going to give me -9, but -3 with its brackets, because then the square also applies to the minus, it becomes a +9. Alright, so my answer is then 4. So this is 4. And then finally, I need to calculate. So I need to calculate sine squared alpha. Now, this notation, if I write sine squared alpha, the notation actually just means the ratio of sine alpha, which is squared. So just to write out the whole thing, I can rewrite that as sine alpha, which is squared, and then times by tan alpha. So now I just substitute in my values. My value for sine alpha is opposite over hypotenuse. So opposite over hypotenuse is 4/5 squared. And my value for tan alpha is opposite over adjacent. So opposite over adjacent. So that's 4/-3. And the question says calculate without the use of a calculator. But at this point, where you already have substituted your values in, at this point you can use your calculator just to simplify this final answer. So we can substitute it in just like that. So we have 4/5 squared times by, we actually don't need brackets for this final one, times by that 4/-3. So this gives us -64/75. So -64/75. Alright, and then B, we have 5 tan alpha minus 1. So we have 5 for tan alpha. I substitute in opposite over adjacent. So that's 4/-3 minus 1. And then we put that into the calculator. We have 5 times 4/-3 minus 1. So this is -23/3. -23/3. For question 4.2, we have if 4 tan beta plus 3 equals to 0 and tan and sine beta is greater than 0, evaluate the following. Now, for our step 1, we solve. So we have 4 tan beta plus 3. So we take the 3 over. Then I have 4 tan of beta equals to -3. And then we divide both sides by 4 to get tan beta on its own. So this then gives us -3/4. Right, that was solved. Then to sketch, I need to determine in which quadrant do I need to draw my sketch. Now, this restriction looks a bit different. This says where is sine of beta positive. So we know that sine beta is positive in this quadrant and in this quadrant. And then we need to see where is tan beta negative. Tan is negative in the fourth quadrant and also in the second quadrant. So that means we are going to be working once again in the second quadrant. So to sketch, we draw it in the second quadrant, and beta is this angle over here. So if I fill in my values here, tan beta is opposite over adjacent. So now I need to know, where do I put my minus? Opposite, this is a positive. This is where y is positive. So this is going to be 3. Adjacent is where x is negative. So this is going to be minus 4. So now I simply need to solve for my hypotenuse side. R squared equals to x squared plus y squared using Pythagoras. So r is the square root of x, which is minus 4 squared plus 3 squared. And this will give me the square root of negative 4 squared plus 3 squared. So the answer is 5. Then we have 5 over here. Now finally we can calculate. So we want 10 sine beta. Now 10, and then instead of sine beta is opposite over hypotenuse. So that's going to be 3 over 5. Now this is just, if I put this over 1, this cancels with each other. So the 5 goes into itself once and 10 twice. So this just gives me 6. Then for b, I want cos squared beta minus 1. So once again, I'm going to rewrite this. This is just the notation. So this is the same as cos beta all squared minus 1. Now I just substitute in my value for cos beta. Cos is adjacent over hypotenuse, so that's minus 4 over 5. That's all squared minus 1. And let's just put that into the calculator. We have minus 4 over 5. And that's squared minus 1. So this gives us negative 9 over 25. Minus 9 over 25.